In this lesson, we shall focus on trigonometric equations. To start with, we shall actually discuss how to solve question 5.3. Now, this question appeared in a November 2022 exam paper. Right, to determine the general solution of the following equation. We've been given cosine x plus 2 sine x. 3 sine 2x minus 1 equals 0. Okay, now to solve this one here, we actually have cosine x. Okay, so in other words, we have a product of two expressions equals 0, which means that cosine x plus 2 sine x equals 0. Right, if that is the case, or we have the 3 trigonometric sine of 2x minus 1 equals 0. Okay, obviously, if the product of two expressions equal to 0, in particular, product of two binomials, it's a binomial 1, 2 terms. So it's a product of two binomials and the product is 0. It means that each of these is 0 or they are both 0. Okay, now we're able to see at this point that we can be able to transpose the terms. How do we transpose the terms? So you can write 2 sine x equals minus cosine x. Or we can be able to write the trigonometric sine of 2x equals 1/3, like so. We perform a simplification of this here. If you divide by the cosine, we get the trigonometric sine of x divided by cosine x, which equals minus 1/2, or the sine of twice x equals 1/3. Okay, we divide it by the cosine, and we also divide it by the 2, and this gives us the results. Okay, right, now the sine of x over the cosine of x gives us the tangent of x, and this is actually equal to minus 1/2, or the sine of 2x equals exactly 1/3, like so. And then now at this point, we will proceed to get what we call the reference angle. Right, so to get the reference angle, because we actually have these particular trigonometric equations, and we need to always get reference angles. The reference angle that you can obtain from here is obtained by actually getting what we call the arctangent of the positive, always the positive, or we come here and we find the reference angle of this equation here on the far right, and this is what we call the arcsine of 1/3. Arcsine of 1/3 and arctangent of 1/3 can also be written as follows. Now, in other words, it is always possible to write arctangent of 1/2, or the reference angle equals also the arcsine of 1/3. Okay, so this is exactly what we do. Now, at this point, we obviously this one is 1/2. To make sure it's very visible, it's 1/2. Now, we use our calculators to actually be in a position to get the result at this point. And if we do, it is obvious, it's very clear that this is means that the reference angle, the arctangent of 1/2 is actually 26,565 degrees. Or at this point, we're also able to see the arcsine of 1/3, and this is 19,471 degrees. Okay, we have got two equations. We have been able to see that we have the reference angle here, which equals the 26. Okay, now I want to first write a step that is very, very important for us. Okay, we need to recall that we had the tangent of x equals minus 1/2. First things first. So where the tangent of x equals minus 1/2. Moreover, it actually came down to the reference angle, which became 26,565 degrees. Or we also able to get here the sine of 2x equals 1/3. Or we have the reference angle, which is 19,471 degrees. Okay. Now, there are a couple of things we need to recall here in view of our old friend, what we call the cast diagram. Right, the cast diagram is very clear, but also it is one diagram that must be appreciated so much. So in other words, if you look at the cast, right, with the cast, we're able to know that the tangent is negative. In which quadrants? It is negative. For instance, in the second quadrant, but also in the fourth quadrant, it is positive in the first and the third quadrants. Okay. At this point, we are interested, therefore, in the quadrants in which the tangent is negative. And therefore, it means that x is equal to 180 degrees minus 26,565 degrees plus. Now, the tangent itself has a period of 180 degrees. So we have k times 180 degrees, but also k itself is an element of the set of integers. Right, so this takes us to the second quadrant because we have 180 degrees here. And if we say 180 degrees minus 26,565, we're able to get the angle that is required in the second quadrant. Meaning, if we do the subtraction here, we get 153,43 degrees plus, right, plus exactly k times 180 degrees, where k is an element of the set of integers, like so. Okay, but obviously this is not the only case. We also have one case we can actually consider here at this point. For example, because it's also negative in the tangent is negative in the fourth quadrant, meaning we'll have 360 degrees minus 26,565 degrees plus k times 100. K times 100 and right, and 80 degrees. You can have that part there. We can have that part there. All right, so in other words, you can also have that. In particular, if you do this, let me just check what this gives us. For example, if you say 360 minus 26.65, 565, okay. Right, I'm trying to check what we're getting here, 565. Right, so we're getting 333.43. Yeah, so we're getting here, for instance, x equals, right, the 360 minus that would give us exactly 333, 43 degrees plus k times 180 degrees plus yeah, k times 180 degrees, and k is an element of integers. Okay, good. Now we continue to look at the other part as well. So we've exhausted the two quadrants, the two quadrants of interest, namely the second and the fourth. Okay, now looking at the other quadrant, the other equation, right, and obviously focusing on the quadrants where the solutions lie. At this point, the sign, we know it's positive here because it's the sign to x is positive 1/3, and we found the reference angle is positive in those in the first and the second quadrants, and which therefore means that our x here is actually exactly 19. Our x is actually 19,471 degrees plus. Okay, now we have this, which is 360 degrees times k, where k is an element of the set of integers. Okay, remember it's 2x. It's 2x. It's 2x. Right, it's 2x. So in other words, obviously now 2x equals this here, but then you divide right through by 2. Now 19 divided by 2 is 9,74 degrees. If you divide 360 by 2, we get 180 degrees, where k is an element of the set of integers. Okay, so we have found a solution, a set of solutions in the first quadrant of the plane, but now we continue to find solutions also in the second quadrant. And in the second quadrant, we're going to use the 180 degrees minus 180 degrees minus the reference angle, which is 19,471 degrees plus 360 degrees times k, where k is an element of z. Right, let's find the difference. If you say 180 degrees minus that one, so right, we can quickly do that. So 180 degrees minus 19.471. 180 degrees minus 19.471, we're getting 160. Right, so it's 160 with a comma, so it's 160 decimal comma. Right, 160 comma 529. Right,
so round it to 2 decimal places.
Thank you so much. We can always round off to 2 decimal places, but obviously preferable for the end. But yeah, we can always round off to 2. So yeah, we can write 5.3. It's 529, but yeah, 5.3. But obviously it's always advisable to round off in the end to avoid discrepancies. But obviously at this point, very negligible discrepancies can always arise. So in any event, you can always round off there. Okay, dividing by 2 will give us 80. 80 decimal comma 2645, but yeah, that'll give us like 26 degrees. If dividing 360 by 2 is 180 degrees times k, where k is an element of the set of integers, so that gives us the solution here. So right, so we have got these answers there. Okay, so we're good. We're so good there. All right. And therefore, what are the solutions to this particular? And obviously, I mean, I've answered the question in terms of the general solution. We found this set of solutions here, solutions there, and solutions there. And therefore, we have been able to solve this particular question 5.3 in a step-by-step manner. And we are done with this question. Let's look at the next question. Right, let's get the next one. In the next case, we need to actually consider the fact that we've been given the identity this identity. We need to prove this identity. Okay, and obviously, I mean, it's pretty straightforward to prove this. Let us proceed to prove this. So we're looking at 5.4.1. And how do we therefore do this one? So to prove this one, we need to let. We need to let the left-hand side of the equation. Okay, we can prove it either way. Either we take the left to produce the right, or the right to produce the left. Okay, it's an identity, and then we shall, I decided to just include this one here. So we have the cosine of x plus y, the cosine of x minus y, which is cosine x, cosine y, minus sine x, sine y. And this is cosine x, cosine y, plus sine x, sine y. Okay, using some of these trigonometric compound angle formulae, we're able to have the following expansions of the trigonometric compound angles. Okay, compound angle identities. Okay, so we have the x plus y, which becomes this. With the cosine of x plus y becomes this, and the cosine of x minus y becomes that. And then what is next? We multiply here. we open up the brackets in the contemporary language of many students. So if we multiply this with that, okay, now this, what is this? What kind of a marble is this? This is like a difference of two squares. Right, so if you look in what we call difference of two squares, what is the difference of two squares? If you have a squared minus b squared, it is a minus b and then a plus b. Okay, yeah. So it's the same thing because it's just cosine x, cosine y, cosine x, cosine y, sine x and y, sine x and y. They just differ by, these two expressions differ by the sign in the middle. Okay, so at this point, we can just multiply these with that, which means it's going to give us cosine squared x, cosine squared y. So just multiply this with that and this with that only. Difference of two squares. So which is sine squared x, sine squared y. Okay, that is what we are able to achieve. And what is the left-hand side? The cosine is 1 minus sine squared x. Okay, you can change the cosine squared and write it as 1 minus sine squared. Simultaneously keep this and return the cosine squared y there. Okay. And then we can also change this one. We can also make the following changes. Because at this point, we can see that there's no cosine x here. There's no cosine y. There is sine x, there is sine y on the right. So meaning that we need to convert every cosine x and every cosine y, which is 1 minus sine squared y.
Wait, I don't understand how you got that last part.
This one.
Yes.
Okay. Right. Okay, that's fine now. Obviously, we remember our grade 11. Cosine squared x plus sine squared x is always 1, and this is true for all x in the real numbers. So at this point, if this is the case, we can be able to realize that cosine squared, let's make cosine squared the subject here, so that cosine squared is the same as 1 minus sine squared x. Okay, so yeah, that is what we have. And therefore, it means therefore, wherever you have the cosine squared, we actually are able to get cosine squared is 1 minus sine squared. But also, cosine squared y is 1 minus sine squared y in a similar fashion. So now this one here is therefore the same as the sine squared y. Okay, sine squared of y. Okay, by distribution, opening up the brackets here or opening up the parentheses, we have 1 times 1, which is 1. 1 times minus sine squared, which is minus sine squared y. Minus sine squared times 1, which is minus sine squared y. And then if you multiply these, okay, this one we multiply everything because it's not a difference of two squares. It's not just plus or minus with the same expressions within the parentheses. So we're going to multiply the sine squared and the sine squared here, and they give us plus the sine squared x, the sine squared y minus sine squared x, sine squared y. Okay. These two guys cancel out, meaning the left-hand side is 1 minus sine squared y. Okay, this by this by that. Let's see. This by this by that, and this. So this is sine squared x. This one is sine squared x. Just take note of that. So after the cancellation, we have 1 minus sine squared y, and then minus sine squared x, sine squared x, like so. And this guy here, it's our old friend. It is exactly what we had. We had this guy here long ago, and it is actually the right-hand side that we have been having for way too long. Right, so obviously, I mean, the examiner just put the sine squared, the x first and the y second, and we're able to do that. and say, therefore, the left-hand side equals 1 minus. So you can just put the x first, because in terms of the English alphabet, so we have x and y, and this is the right-hand side. And this is the answer. This is the answer. So we've been able to prove this identity, and then we can even write the conclusion and say, hence, we're able to see that if we have the cosine of x plus y times the cosine of x minus y, it is 1 minus the sine squared of x minus the sine squared of y. Like so. And therefore, we've been able to prove the identity as the examiner asked. We proceed to the next question. In the next question, the examiner is asking something similar. And the examiner is saying at this point, hence do something. Hence determine the value of this expression without the use of a calculator, or without using a calculator. So let's find the value of this particular expression without using a calculator. First and foremost, we need to realize that to get the answer here without using a calculator, we'd realize that 1 minus the sine squared of 45 degrees minus the sine squared of 15 degrees, which is this, is the cosine. Okay, so at this point, if this is like an x and a y, so this is like an x and that is like a y. So obviously on the other side of this, it's going to become the sum of the x and y. So it's going to be 45 degrees plus 15 degrees. So we're adding up the x and the y, and we multiply by the cosine of the difference of this. So it's 45 minus 15. 45 minus 15 degrees, like so. Okay, now at this point, we're able to find the summation. So what is 45 plus 15? It's exactly 60 degrees, right? And we're 45 minus 15, 45 degrees minus 15 degrees yields 30 degrees, as written. Okay, now we have our old special triangle, and we bring it on board. And we have this guy here, and this is 60 degrees always. This is 30 degrees all the time, and this is 2 to the square root of 3 to 1. Okay. Okay, SOHCAHTOA. SOHCAHTOA. Right, meaning now we have the cosine of 60 degrees, which is adjacent of hypotenuse, which is actually 1/2, and therefore we have the cosine of 30 degrees, which is adjacent of hypotenuse, which is actually the square root of 3 out of 2, like so. And we get the answer to this, and the answer is what? We have the liberty to even write it anywhere. In particular, we can be able to see that this is the square root of 3 out of 2 by 2 is a 4. And that's the answer. And that is the answer. 2 by 2 in the denominator, it's a 4. So we've been able to determine this without using a calculator, and that is something that remains pivotally important, but extremely, extremely important. And look at the next question. Right, in the next case, we have this equation that looks very terrifying, I believe. It has cubic, so you're dealing with cubic trigonometric functions here. Okay, cubic degree of the third degree. This one in particular is the fourth degree, that, you know, because it's the third degree by another variable here, so it's fourth degree. Consider the trigonometric expression, this one here. Rewrite the expression as a single trigonometric ratio. Okay, the examiner is saying rewrite this one as a single trig ratio. Maybe I'm going to give you a chance. You try some of these and you tell me, tell me what the first step is going to be here in 5.1.1. If we have 16, the sign, because you're the only one here on the line. I'm not having other students to intimidate you. The best way to teach a player is to let them play, is to put them on the field of play and say, kick the ball. And that is what is going to make them able. But if we just say to the player, we're going to play for you the whole time, and now then you're able to play, it's a fallacy. It's not the truth. Okay. What would you do first here now? What do you think? I need to engage you a little bit. You'll forgive me for that. What do you think we need to do here? Are you able to see the question? Okay, because the
say
yes.
4
Yeah.
times 4 sine
Okay.
x.
Okay. We'd say 4 times 4 sine x, right? Like 4 times 4 sine x. Like so, okay?
And then
I'm just giving you a chance. Remember, okay, remember that this is saying rewrite the expression as a single trigonometric ratio. Yeah? Yeah, because I'm just giving you a chance. Okay, I'm gonna do this one, then I'm gonna give you the next one. Maybe that is fair. Okay, but we have not seen the next one. Okay, all right. So yeah, okay. You want to say something? We can just wait. That's fine. Okay. First things first, because we need to simplify this. It is an expression. We go to our old friend, the HCF, the highest common factor. What is the highest common factor of 16 and 8? The biggest one.
it's 8.
8. So we can take out 8. So we're done. Okay, 8 has been taken out, but now we need another common factor. Sine x, anything else? We can see that the sine x is also sine x, right? So we can take out sine x. Okay, we want to take out the highest common factor, so we're looking at each of these expressions. There's cosine x, there's cosine cubed, so we can take out cosine x, like so. And upon careful examination, if you then do division inside the expression. So you say 16 divided by 8. What is 16 divided by 8? Okay, that one gives us a 2. Because the sign has been taken out, you can do this. Okay, this sign has been taken out, so you cross this out. The cosine has been taken out, so you cross out. Okay, we take out one cosine, we're left with 2. Okay, so in other words,
2 cos squared
cosine
x minus
squared.
1.
Well done. Cosine squared x, then minus 1. Okay, what is next? This was a bit tricky to most students. Anything else? Anything else? Anything else? Anything else? Okay, I'm just yeah. What do you think, Noah?
Cos 2x.
Cosine 2x. Here, it's cosine 2x because we know that cosine 2x is actually 2 cosine squared x minus 1. So, which means that we have 8 sine x cosine x. Okay, and this is cosine what? 2x. Okay, which is 4, open bracket. We can take out a 2 here, giving us 2 sine x cosine x. We just extract and factor out 8 to 4 times 2, and it gives us this. What is 2 sine x cosine x? What is this equal to? It is actually this guy alone. We know that the sine of 2x is
Isn't that
2.
cos 2x?
Yes. Okay.
You wrote cos
There's a
x.
2. Yes, there's a 2. There's a 2 that's missing, right? I'm happy that your eyes are wide open. It's cosine 2x, so we carry it forward. I agree. Okay. So well done there. Okay, and thank you for noting that. Okay, now if you're looking at the fact that we factored out 8, and 8 can be factorized into 4 times 2. And now what is I was writing here that sine 2x is 2 sine x cosine x. Okay, yeah, so we have that. So what is the next thing that we have here? Okay, yeah, this one is sine 2x, and then this one is cosine 2x. Then what do we do next here now? Anything else? Because, okay, the objective is to write it as a single trig ratio. I'm just giving you a chance. The objective is just to write it as a single trigonometric ratio. I'm just giving you a chance. Yeah, what do you think? Any thought? Any idea? What is the next step? Or what would, that's a good question. What is the next step? Your thoughts? I'm giving you a chance to engage because you're the only one here talking to me, you know? So I'm trying to engage you so that you can learn and become a good citizen of South Africa. Right. So obviously, I mean, you're a citizen of a country and you can become a citizen of the world, of the globe. Okay. But yeah, we can take out another 2. and write 2 sine 2x cosine 2x. I'm going to engage you, forgive me. Okay, just engaging a little bit. Okay, what is 2 sine x cosine 2x? What is the answer here?
It's
Yeah.
cos 4x.
Cosine
I
for
mean,
x.
I mean,
It is
what?
sine for x. Well done.
Yeah, sorry, sine 4x.
Okay, yeah, but you're on point. You're on point. Okay, now you can be able to write these like that because sine 2x is 2 sine x cosine x, which means it is 2 the sine of 4x. 2 the sine of 4x. And now this is the answer. So now writing this one here is actually 2 the sine of 4x. 2 the sine of 4x. Okay, yeah, 2 the sine of x. And then we're done with that question there. So yeah, it's something that you need to take note of. So make sure that you understand that and you are able to move on to the next question. So let us move on to the next question. We're looking at 5.5.2.
Yes, Maras.
Yes, yeah, I'm in class now. How are things?
It's all is well, Maras.
Yeah, okay.
Yes, Maras. Things in Simbrango, man.
Okay, yeah, let me get back to you when I'm done with my class at 12. Okay. Yeah, because I'm just in class now. I don't want even my students to be hearing your stories. Okay. Thanks, Kakul. We'll talk then. Okay. Right. Consider the trigonometric expression, this one. For which value of x in the interval x between 0 degrees and 9 degrees will 16, the sine of this, have its minimum value? Okay, for x between like 0 and 90, it's 1 mark, like 1 minute. But yeah, okay. You'd have to remember something. I'm gonna give you a chance to answer that one. And yeah, I'm gonna give you a chance to answer that one. But I'm just gonna write some background here as you're thinking about it. It's okay. You're thinking about it, and okay, I'm gonna write it as okay, we know this one. Okay, we know this one. What is this one? We know that this one here is actually the same as
Isn't it gonna be negative
yeah.
90? Negative 90.
Yeah, you're on point because okay, we're thinking about the minimum value. Okay, yeah, let's think about it. Let's think about it. But okay, you want the value of x. For which value of x? Okay, but if you have 16 the sine of x, cosine cubed x, minus 8 sine x, cosine x. Okay, and this guy, this expression is equal to this, and this becomes an identity because this equals this. It's an identity. Okay, because it's true for all values of x. Okay, it's called an identity. It's a law. Now, this is a law in trigonometry. Now, for which value of x in the interval will this expression have its minimum value? Yeah, you were trying to say something. Please say again now. I cut you short. I was trying to just elaborate a little bit. Yeah, what do you think?
I said x is 90, negative 90.
Okay, x is negative 90. Okay, that's fine because we're learning here. But remember that x lies between 0 degrees and positive 90. So the examiner is saying there are many, but just choose the angles between 0 and 90. But just like, don't go out of this interval. So minus 90 might be correct. But the examiner says, hang on, please, don't take, I get your point, I hear you. But the examiner says the x must be positive. It can't be negative. You know, I agree, negative 90 makes sense. But it is outside this interval. We need something between 0 and 90. You get the point? So what is the next thing that we need to do here? I agree with you, minus 90 makes a lot of sense. But the examiner is saying, hey, students, don't go far, please. We want the minimum between 0 and 90. Positive angles only. No negatives. No negatives. Right. So remember, these questions are past exam questions. They're not questions from my head. It's not that I'm just bringing them here. No. Right. For which value of x in the interval will this expression have its minimum value? Minimum value. Okay, so obviously we're thinking. Right, so I mean, you need to think and reason. Yeah, what do you think? No, it's tricky. It's tricky. Okay, the minimum is going to be at minus 90, yes, but there's also 270. But 270 is outside this. Hang on, the examiner is being tricky because the examiner knows that the students are going to think x can only, but now remember, we are dealing with 4x here. So it is 4x. That is 270 degrees. Because the 270 is positive, but it is not between 0 and 90, but we need to divide it by 4, remember? So we're going to have divided by 4.
Okay, so which one do I look at? Do I look at 2 sine 4x?
Yes, we look at 2 sine 4x because this whole thing is too
I look at this. I look at the angle of 4x.
Yes, we look at the angle of 4x because, well, the truth is we can think about this.
Because they're equal.
Yes, because they're equal. And this is simpler to analyze than this because this is just too many things here. That is why the examiner asked us to simplify. So we have that. So we divide by 4 and we're getting what? X equals. Okay, now let's come to this. What is 270 divided by 4? Okay, we do that on a calculator. And we do 270 and we divide that by the angle 4. What does,
Why is it equal to 270?
or why is it 270? Okay, 270 because we're dealing with the minimum. And we know that the sine of 90 degrees is 1. And you mentioned minus 90, and minus 90 makes sense because it is minus 1. But we also know that the sine of 270 degrees is minus 1. So the sine has its minimum at 270, you know? Because the sine of 270 is a minus, it's a minus 1. So that's
But
why
it's outside.
yes, it is outside. But remember, okay, we divide by 4. Remember, we must divide by 4. That is why the examiner put it between 0 and 90. We must divide by 4. Here, okay. If we suggest, therefore, that this 4x can be 270 because 270 is a positive angle, and therefore divide by 4 positive, right? So we're going to have, therefore, 270 divided by 4. Okay, what is 270 divided? So we have 270 degrees, we divide it by 4. What is the answer? 270 divided by 4 is actually 67, 5. So it is 67,5 degrees. And it is actually, this 67,5 degrees is actually an angle that lies between 0 and 90. Any question?
Can you explain again
Okay.
how you got
Okay.
270?
Yeah, we got to 70 because the examiner is looking for which value of x.
Outside 90.
Yes, it is outside 90. But the answer that we got, the x that we got is 67,5, and 67,5 is between 0 and 90. You know? So it was a slightly tricky question because we had to look for the minimum value, and the examiner knew that the students will think the minimum is going to be at minus 90 because the sign of minus 90 is minus 1, but not only at minus 90.
So you didn't choose. Okay, negative 90 was also fine, but you didn't choose it because it
It's
would be
gonna be
negative. It would be a negative answer.
Yes, it's going to be a negative answer, and the examiner needs only positive answers. You know, the values of x must be between like 0 and 90 degrees. So, and 270 also, so the sign of minus 90 is minus 1. The sign of 270 is also minus 1. But the 270 is more appropriate because it's a positive angle, right? Okay, right. So yeah, good. We're so good. We're so good. So we proceed to the next question. Next question, please. Okay, let's look at the next thing. Determine the general solution of this particular question. Determine the general solution of this particular question. Right, so now you need to reason, you need to think, yeah, so I know that you're thinking big as well. So what would the answer be to this particular question now? And you see, it's very rich in marks because this question was given plenty and plenty of marks. How many marks was it given? 7 marks. 7 marks. And these 7 marks are a lot of marks. Yeah, what do you think now? What is the first thing? First thing
Gonna factor out sine x.
can you factor out sine x? Okay, let's check that one. Can you factor out sine x? Very brilliant, brilliant idea. We can factor out sine x. Let's do that. So if we factor out, so yeah, so in the exam, obviously you need to first write a solution like this. So we are writing the question. So it is sine x cosine x plus sine x equals 3 cosine squared x plus 3 cosine x. Okay, we factor out sine x. Bring the idea from there, giving us cosine x plus 1, which equals, and then what next? What do we
Factor
do
out
next?
3 cos x.
We factor out 3 cosine x. And if we do that, we're left with what?
Cos x plus 1.
Cosine x plus 1. Okay, good. And this is what we get. Then what do we do next? We're trying to reason here together. What do we do here next?
We try to make them the same.
We try to make them the same. Well done. Okay, now we can collect like terms. We collect like terms, and now we also transpose things a little bit. Okay, we can just move this on the other side. And there is the highest common factor. What is the highest common factor here? What is the highest common factor?
Cos x plus 1.
Cosine x plus 1 is the highest common factor. Well done. And we then have this sine of x minus 3 cosine x equals 0. Then what do we do next at this point? What do we achieve here? What are we able to achieve here? What are we able to achieve? Okay, I mean, we go to this point and then we can solve everything. So which means that cosine x is minus 1 or
Sine x is equal to 3
cosine x, right? And then what do we do? And then what do we do here? What?
Reference angle.
Yeah,
Find
okay,
the reference.
we get our reference angles. Well done. We get our reference angles. Okay, before we get our reference angles, let's just write a trivial step here. Cosine x is minus 1. And then here we can divide by the cosine. And this is cosine, which is 3, right? And obviously it gives us 10x equals 3. And this is cosine x equals minus 1. Or, so what do we do here? We get the reference angles. And what is the reference angle here? Reference angle. What's the answer?
So how do you know when you're supposed to?
Yes.
How do you know when you're supposed to transpose the other equation to the other side?
Okay. You mean like this one, this equation?
The third step.
The third step. Okay, this step here?
The third one from the top.
From the top, 1, 2, 3. Okay, yeah, we transpose it to the other side. Yeah, because it was clear that we had a common factor, and the common factor.
So how do you know when you're supposed to, like, minus 3 cos x? Because sometimes they say you must change cos x to sine, or sine x to cos x.
Yes. So please ask your question again. How do we know if we need to minus?
Yes, you look at the common factor cos
Yes,
x.
because cosine x plus 1. And the cosine x plus 1 was there to give us a solution as well. But also, there would be a wrong thing with the students. I mean, for example, if a student is given 2x squared equals x to solve for x, how does one solve for x here? You see, there are mistakes. So the way to solve for x is to do this. That is the correct way to solve for x. And then you take out the highest common factor and so on. Like so. Minus 1 here.
Yeah, next.
Okay, yeah, I'm just giving this one. I know it's very easy, but yeah, it's the kind of stuff you meet in algebra. Okay, and then you solve. X is 0. X. I'm just solving this for anyone who's going to watch this because I'm going to make this video available for people to watch during their own leisure and just to, participate and see how we solve these questions. But now, there is a mistake the students can do. What mistake can the students do? A student can say this x squared equals x, and they can divide by x. The students who can think like this and say, okay, we can just cancel the x out. And if you do that, you have 1, 2x, and then x equals 1/2. What is wrong with this? The student is getting only one solution, and one solution is lost. The x equal to 0 solution is lost. Okay, so and a student can see this and they can divide by cosine x plus 1 and then cancel and then say, okay, then we simplified everything and the whole thing is simpler, but it will be wrong to lose a solution. So in mathematics, we do not quite divide by variables that can potentially be 0. When solving equations, we must have, I'm just mentioning that so that, we are on the same page, but we make sure that we think correctly and we avoid errors in reasoning. Okay, that is something that remains pivotally important for us. Pivotally important. Okay, yeah. What is the reference angle here? The reference angle here is arc cosine of 1. Or here we get a reference angle, which is arc tangent of 3. Okay, I'm writing the arc tangent like this, but yeah, it can also be written this way with the exponent minus 1 there. This one becomes sort of it's called the arc function. Arc function. Okay, now this is the reference angle. What is arc cosine 1? It's 0 degrees. Okay, and therefore here you have the reference angle. Arctangent 3. Arctangent of 3. What is arctangent of 3 here? Arctangent of 3 is actually 71.57 degrees. So what do we do next? Okay, now we got the reference angles and then we just need to get the answers. But now we remember that for the first part here, if you have the reference angle is 0, we have our cast diagram. And the cosine is negative. In which quadrant is it negative? In which quadrants? Quadrants is it negative? It is negative in the second and the third. Okay, good. That's where the cosine is negative. So we're going to need an angle in the second quadrant. And so that is going to be exactly the 180 degrees. So, so x is going to be the same as. So x is going to be the same as 180 degrees minus 0 degrees plus 360 degrees times k, k in an element of the set of integers, right? And this gives us 180 degrees plus 360 degrees by k in z. Okay. All right, all right. Or we can also find another angle in the third, but it's the same because the reference angle is 0. So you'd have 180 degrees plus 0 degrees plus, okay, obviously we're adding 360 by k because the period is 360 for the cosine. And therefore 180 degrees plus 0 degrees gives us 180 degrees plus 360 degrees by k and z. Okay, you are just giving some little questions here. And then the cosine, the tangent now is actually an angle that is right. So obviously now we're dealing also with the tangent here, and the tangent in view of the cast diagram. Right, so in view of the cast diagram, we have the following. Right, so in view of the cast diagram, the tangent is positive. Positive. So it is positive where this tangent? This tangent is positive in the first and the third. Okay. So, which means therefore we're going to use the first one is x equals 71, 57 degrees plus 300 plus 180 for the tangent, 180 degrees by k in the integers, right? K in the integers, but also we have another one, or x equals, sorry, yeah, this is 180, it's 71, it's an angle in the first quadrant, but also there is an angle in the other quadrant, okay, namely in the third quadrant. And so how did they forget the angle in the third quadrant? Okay, which is already part of this, because it's already part of this. So you can also say that you have 71,57, yeah, it's 180 plus, but yeah, but it's already taken care of. Let me just write that one up here. So you're gonna take this one and take it up to the top here, and then say that we have x equals 180 degrees, and then we add 71,57, but these are circular functions and these are periodic functions, so it's 180 degrees by k. So this one is not necessary to do in the matric exams. So we have 180 plus 71, in 180 plus 71 is actually exactly the same as the 251 point that. 251 point that, okay? Let's make sure we cross-check our things. So we have 180 plus 71.57 degrees, and it is 251.57 degrees plus 180 degrees by k and z. Okay, pay attention and note that at this point, this solution is enough, and this one you can leave out in the exam. Why? Okay, you can leave this one out because if k is 1 here, you already have 180 degrees plus 71,57, which is already 251,57. So this solution here and this one are exactly the same. This and that are the same. Somebody can be like, okay, but this one was obviously in the first quadrant, and this is in the third quadrant. But obviously, we're able to see that the 71,57 degrees is actually an angle that is in the first. Yet now 71,57 plus 180 gives us 251,57, and those 251,57 is an angle that is here when k is 1, can be obtained by this equation. And therefore, yeah, there's no need for us to go to third quadrant for this particular question, but always have your eyes open and your mind open. Any question, any remark, any contribution, anything to change here now? Right, you can let me know.
It's fine.
It's fine, thank you. Okay, good. Let's move to the next one. Okay, now let us play around with some identities. This can be a little bit tricky because, I mean, you need to decide what to do. And so, how do we prove this one? Okay, to prove it's easy, no one's going to think of that. Okay, but proving it's straightforward because we just do what? We just take one side and produce the other. Okay, we're doing 5.3.1. We take the left or the right and produce the other. Okay, so let's we are doing 5.3.1 and we are trying to prove this. So we have this sine of 3x. I'm going to suggest we take the left, but you can also take the right and produce the left. You can also do both sides of this. I mean, how do we do this one now? What do you think? I'm just testing you before we do it. Before I do it together, but what can we do here? Suppose you walk into these, boom, you see these. Okay, yeah, the other paper is coming, remember? There's a paper that is coming, the term 2, June. It's coming. Paper 2, I think. I think they've not written that one yet. You see, I showed you the Gauteng paper 1. Okay, now there's paper 2 that must come. And I'm sure that I would like us to discuss those papers. If we don't discuss them, I'm going to give them to you. And you try, and then I mark. Okay, that is one thing that we're going to do. Okay, but let's try this one. 5.3.1. We need to prove this identity. We're going to do it together. Of course, I agree. But what can you throw in as an idea here on what you think the best way to tackle this is? There are many ways to do it, but yeah, any suggestion, any idea?
Mm.
Any idea?
Yeah.
It's tricky. Yeah.
It's
I'm
because
just
they
giving.
look like
They look
like
similar.
the yes.
They look similar because this one is sine x at the top, and this one is sine x at the bottom, and this one is 1 minus cosine 3x, and your. I mean, what is the first step? What can we do? There are many things that can be done, like a billion things. Yeah, but just one. Just one. Okay, yeah, this is what you can do. I'm just sharing the idea. Never mind that. Okay, if the identities in the exam are like this, they just switch places. Like the sine 3x is in the bottom, and now the 1 minus cosine becomes 1 plus cosine. So yeah, you need to know that this becomes a brain teaser. It becomes a brain teaser. What brain teaser? We put a plus. We put a plus. We rationalize to introduce the plus, the 1 plus cosine 3x. We rationalize.
What rationalize?
Yes, we rationalize. At this point, we rationalize.
Oh, how does rationalizing work?
Okay, how does rationalizing work? Okay,
For
so
the numerator.
yeah, so we're rationalizing the denominator. So yeah, we are rationalizing the denominator. Okay, in the way we should, yeah, please come again.
Can you show example for numerator when you
Okay.
rationalize it?
When you rationalize the numerator, right? Okay, good. Yeah, we can rationalize the numerator. For example, we can have 1 plus the square root of 3 and divided by 4, for example. Okay, let us rationalize the numerator here, and that is the instruction. So we want to rationalize the numerator. How do we rationalize the numerator? So we have 1 plus this and 4, and we multiply by the conjugate. We multiply by the conjugate. Okay, see something called the conjugate? Right, so if we multiply by the conjugate, we change the sign in the middle, and then 1 by 1 is 1. So yeah, if you multiply by the conjugate, just multiply 1 and 1, and then multiply the square root of 3 by negative square root of 3, and you get 3. Right, and you have 4, for example, 1 minus square root of 3. Just doing this for anyone who is interested in just knowing what the answer is going to be to this one. 1 minus 3 is a minus 2. 4, okay, 4 open bracket. 1 minus the square root of 3. Right, so your 1 minus square root of 3. Divide right through by 2, which is minus 1 over 2, 1 minus square root of 3. Okay, so yeah, this would be an example of us rationalizing the numerator. Okay, I mean, in the end, if you're rationalizing the numerator, it means therefore the numerator was irrational. It was irrational, and we have made it rational. And how do we make it rational? By multiplying by the conjugate. The conjugate of 1 plus 3 is, you can write here and say conjugate. Conjugate of 1 plus the square root of 3 is 1 minus the square root of 3. Okay, this is conjugation. It's called conjugation. So we do that. Any question, Neo?
No, it's
No
fine.
question. Okay, it's okay. So okay, now we gonna tackle these ourselves. Okay, it came in one of the exams, and we are playing around with the past exam questions, and want to see what it comes under equations. What is asked under equations? So we rationalize the denominator, and if you rationalize the denominator, it becomes the easiest one to write, because just multiply 1 by 1, we get 1. Just multiply this by that, we get minus cosine squared of 3x. And then we write the numerator as the sine of 3x. Okay, we write as the sine of 3x. The sine of 3x, and we have 1 plus cosine 3x. Okay. What is 1 minus cosine squared 3x? What do you think, Noah? What do you think the denominator is the same as?
It's
I'm just teasing you. I tease you sometimes. That just to keep your mind active, you see? Because it's the best way to learn. To teach an athlete how to play, you need to keep their minds active. Yeah?
sine squared 3x.
Well done. Sine squared 3x. Sine squared 3x. Now, that's correct. Okay, so if it is sine squared 3x now, this one is going to cancel one factor, giving us 1, because here is sine squared. Sine squared is like sine 3x, sine 3x. So yeah, it's going to cancel one of them, giving 1 plus cosine 3x, all divided by the trigonometric sine of 3x, which is this guy. And this is equal to the what? The right-hand side. It is equal to the right-hand side. Okay, so we've got 1 plus cosine 3x over sine 3x. And so we can conclude and then say hence. And then say hence. Now, the sign, obviously we can say this first. And say hence the left and the right are equal to each other. Hence the left-hand side equals the right-hand side of the trigonometric equation. Moreover, thus we can say the trigonometric sine of 3x we divide by 1 minus cosine 3x, and this is 1 plus cosine 3x we divide by sine 3x. Like so. And this is the answer to this. It's the answer to this. Any question, Chanel? Any suggestion?
No.
No suggestion. Okay, good. Let's move on to the next one. And now we've proven this identity. Let's move to the next one. We're looking at 5.3.2, and this one says determine the values of x in the interval x, an element of this interval between 0 degrees and 60 degrees, for which the identity will be undefined. How do we deal with undefined identities? And what are the values of x? And what do you think?
It's when the denominator is 0.
It's when the denominator is 0. Excellent stuff. It's when the denominator is 0. So when is the denominator 0 here? What do you think? Right, so it's undefined. It's undefined when? When the sine of 3x is 0. And also when 1 minus cosine 3x. So consider both. We'll consider both 3x equals 0. So undefined when the sine of 3x equals 0 and 1 minus cosine 3x equals 0, right? Okay, because we take like both sides. We consider like everything, like entirely everything. And then what do we do now? What do we do now?
0 divided by 3.
Yeah, we can do that.
So sine x is 0.
Yeah. So we're gonna find our usual stuff and our things. What do we call those? The reference angles. So now we're dealing with the reference angle. The reference angle of this one is gonna be arc sine of 0. Okay, obviously this one here can be seen as cosine 3x equals 1, and that means that you can be able to find a reference angle and say the reference angle is arc cosine of 1. And what is arc cosine of 1? We thought that is 0 degrees. Okay, and arc sine of 0, arc sine of 0 is 0 degrees as well. Okay, now at this point, when is the sine 0? And when is the cosine 1? The sine is 0. If you look at the cos diagram, 0 degrees, 90 degrees, 180 degrees, 270 degrees. Right, so we are in business. We are in business. So now at this point, we have this, and when is the sine 0? The sine is 0 in two places. It is 0 where the sine is 0 here at 0 degrees, but it's also 0 at 180 degrees. The cosine is 0. Now, if this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, obviously here we have our 360 degrees, as much as we have our 360 degrees here as well. Now, the cosine itself is 0 at multiple places, or rather the cosine is 1. Right, at multiple places. It is 1 here at 0 and 360 degrees, but at 180, the cosine of 180 becomes exactly a -1. Okay, now we are in business and we're able to see this, and we say 3x. We have 3x equals exactly 0 degrees. So we have the sine of 3x equals 0. So we have 3x equals 0 degrees. Or we have actually another case. So the sine is 0 in two places. It is 0 at 0 degrees, but it's also 0 at 180 degrees. So obviously, which means that the 3x is 180 degrees as well. We divide both left and right by 3 here, getting 0 degrees divided by 3, and this gives us 0 degrees, or x equals, we have 180 divided by 3, which is 60 degrees, like so. So in the end, then what do we have here? And which means, therefore, now you have cosine 3x equals 1, and it means what? Okay, we found that the reference angle is 0 degrees. So if the reference angle is 0 degrees, it means that 3x is equal to 0 degrees, right? Or we can say 3x equals 360 degrees. Okay, we noted that the cosine is 1, cosine 3x is 1 at 0 degrees and 360 degrees simultaneously. Okay, now we continue. Dividing by 3 here, we have x equals 0 degrees, or x equals, okay, you divide here by 3, and you divide here by 3, you get 120 degrees. But now we are interested in the angles that lie there, so we need to make choices and then say hence. We need to conclude here and say hence. X equals 0 degrees because it's there. X equals 60 degrees. This one, 0 degrees. But yeah, the 120 is out of the picture. So this one is not applicable here because of the fact that we're dealing with the angles between 0 and 60 degrees. And therefore, this becomes the answer. Here, any question now? Any
Explain. Can you please explain?
Okay, good. Right, we're effectively saying here, remember that our X lies between 0 degrees and 60 degrees. So between 0 degrees and 60 degrees, we have got 0 degrees here, divided by 3, divided by 3, 180 divided by 3, 60 degrees, and divided 0 degrees by 3, getting 0 degrees. And we have 360 divided by 3 is 120 degrees. So we're interested in the angles between 0 and 60 degrees. 0 degrees, X is 0 degrees, so we're going to take that as our answer. But also X equals 60 degrees, we're going to take this one, that one as our answer. But X is 0 degrees. Yes, we've already got that one, so it's taken care of. X equals 120 degrees. 120 degrees, no, it's not. Why? Why would 120 degrees be out of the picture? It is out of the picture simply because we are dealing with angles between 0 and 60, and 120 is way too out. It's too big. It's too big of an angle that is wanted, so it's not applicable. And therefore, the two answers, 0 degrees and 60 degrees, which are the ones that are wanted. These are the ones, these two angles are the ones for which the identity will be undefined. Any idea there? Any question, contribution, remark, anything to add now?
Okay, so that's the final answer. X
That's
is
the
0.
final answers. Is X is 0 or X is 60 degrees? Can you even write like that? Can you even write X is 0 or X is actually exactly 60 degrees? X is 0 or X is 60 degrees? Yeah, that is the answer. So any question? No question.
No.
Okay, that's fine. We just practicing here. There's no fuss. So we're just practicing with these past exam questions. Let's go to the next one. Okay, here comes the next one. And the next one is as good. Right, without using a calculator, simplify the following expression to a single trigonometric term. Let's look at this one. Right, we need to simplify this to a single trigonometric term. What is the first step here now? What do we do first? We need to simplify it. Where do we start? I'm just teasing you because I want to do it. Yeah, I want to like know what you think about the question.
Reduction.
Reduction formulae, right? Right. So we look at reduction formulae. So we're going to reduce angles. Okay. So the couple of things we can do. So yeah, I mean, how to reduce? What angles do we reduce? I guess that's the question. What angles would we reduce here?
Cos 440.
Cos 140. And how do we reduce cosine 440? To what angle?
Cos 440 minus 360.
Cos 440 minus 360. Right, well done. Cosine 440 degrees minus 360 degrees. Well done, you can always write like that. And then, what next do we do?
And then...
I'm just teasing you. I just need to know what you think. Yeah?
You're going to get cos 80.
And then you're going to get cosine 80 in the denominator. You're going to get cosine 80 degrees. I agree with you. Okay? Then the rest of the other things like sine 10, what do we do with them?
Sine 10 is going to cancel cos 80.
Okay, sine 10 is going to cancel cosine 80. Okay, why?
Because it's cofunctions.
Cofunctions, well done. Cofunctions. So in other words, cosine 80 degrees for sine 10. Sine 10 degrees equals cosine 80 because these are cofunctions, but also 10 degrees and 90 and 80 degrees. When you add them, you get 90, and they're called complementary angles. Complementary angles. Okay. The complementary angles are those angles whose summation is actually 90 degrees. So if you add the 10 and the 80, you get actually 90 degrees. And these are called complementary angles. And now when you add them up, you get that. So yeah, in the unit therefore, we have the sine of 10 degrees. In which quadrant is now, what about the 360, the tangent of 360 minus theta? What does it become?
It's gonna be negative 10 theta.
It's going to be negative tangent of theta. Well done. Negative tangent of theta. And therefore, we can remove something here. We can remove this little bit. We can remove this little bit. We can remove these little bits. Okay, we continue then. We
And
continue
then
then. Yeah. What do we do next?
then the sine 2 theta, you're gonna split it to 2 sine theta cos theta.
Yes, then we're going to split the sine as usual to the compound and formula. And it's going to become what Noah is saying there. It's going to become exactly 2 sine theta, 2 sine theta, cosine theta. Right. Next, what do we do?
And then negative 10 theta is gonna be negative sine over cos.
We can write it in the form sine over cosine. The sine over cosine. All right. So yeah, we're going to write sine over cosine. Okay, that's what we're writing. That is what we're writing. Okay, so it's sine over cosine. Okay, and therefore it is sine theta over cosine theta. That is the tangent of theta, and then we have 2 sine theta, cosine theta. Any input here now? What do we do next?
Then you cancel the cos theta.
We cancel the cosine of theta. We cancel the cosine of theta. So this one cancels out, and then what do we achieve?
Then we get negative 2 sine squared theta.
Then we get negative 2 sine squared theta. So for a kid who does not know that the sine of this here, the kid can make this one the same. The kid can be able to write here this one, the sine of the 10 can be written as 90 degrees minus 80 degrees divided by cosine 80 degrees minus, so it's minus 2. Sine by sine is actually sine squared of theta. Okay, so now the 90 minus is in the first quadrant. In the first quadrant, because if you have 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, and if you have 90 minus theta, and then you have 90 degrees plus theta. So the 90 minus is it's actually in the first quadrant, in which by the cast rule, all the trig ratios are positive, so it's going to be positive, but it changes to its cofunction, the cosine of 80 degrees divided by the cosine of 80. Okay, it is 1, I agree with you there, but I'm just writing some little bit of elaboration. So this is 2 sine squared theta, and then cosine squared over cosine of cosine 80 degrees divided by cosine 80 degrees is the 1 minus the sine squared of theta. What is 1 minus 2 sine squared theta? Yeah. Yes, this one here. Can you simplify it?
How did we get 1?
Please come again.
How did we get 1?
Okay, how did you get 1? We divided cosine 80 degrees by cosine 80. Right?
Yes.
Yes. Okay. And therefore,
It's gonna
obviously,
be,
yeah.
it's cos 2 theta.
Cosine 2 theta. Well done. This is cosine 2 theta. And this actually is the simplified expression. There's no further simplification that is possible because the question said without using calculator, simplify the following expression to a single trigonometric term. And this is a single trigonometric term. And we're done. We're done. I completely solved this problem here in front of you. Okay, so we move to the next question. Right, the next question is aggressive. The next question is an angry question. It is 6.2.1. Given the sine of 60 degrees plus 2x plus the sine of 60 degrees minus 2x, calculate the value of k. The value of k if the sine of 60 degrees plus 2x plus the sine of 60 degrees minus 2x equals k cosine 2x. What do we do here now? What is the first step? What would you do first? What do
gonna
we do first? We want to
compound.
find this k, yeah?
Going to break it up into its compound.
Compound angle formulae. Compound angle formulae. So with the sine of 60 degrees plus 2x plus the sine of 60 degrees minus 2x, which is k, the cosine of 2x. So the sine here can be further expanded to the sine of 60 degrees cosine 2x plus cosine 60 degrees, the sine of 2x plus cosine 60 degrees. Let's put this sign here. So we have here the sine of 60 degrees. Right here we have the sine of 60 degrees. And then we have cosine 2x minus, for this one here, cosine 60 degrees, the sine of 2x, and the result is k cosine 2x. Okay, what do we do next, Noel? What do you suggest we do?
Sine 60 is square root 3/2.
Sine 60, the square root of 3/2. Okay, good. But before that, this guy and this guy cancel out. Cosine 60 sine 2x. Cosine 60 sine 2x cancel out. And we have the sine of this and that, are like terms. And if we add them up, we have 2, the trigonometric sine of 60, cosine 2x, and this is k cosine 2x. And I agree with you now that at this point, if this is 60 degrees, the square root of 3 here, 2, 1, the sine of 60 is actually the same as, if you count here, the sine of 60 in view of SOHCAHTOA. In view of SOHCAHTOA, sine of 60 is the same, it's opposite of hypotenuse. So 60 is opposite of hypotenuse, which is the square root of 3 out of 2 cosine 2x equals k cosine 2x. What do we do next? What do we do next?
You divide k cos 2x by cos 2x.
Y'all can always do that. Good. The 2 cancels out first things first, giving us the square root of 3 cosine 2x equals k cosine 2x. Yeah. We divide. Okay, now there's always an issue with dividing with an unknown, so I would say doesn't matter. You transpose the things. But yeah, in this case you can divide, but I don't want to teach division by functions of variables. It's problematic sometimes. So we have cosine 2x. Right, so here we would have cosine 2x, which you take out, which is the square root of 3 minus k equals 0. which means, okay, this is cosine 2x, which means we have cosine 2x equals 0, or k equals the square root of 3. Okay, this would be a very normal way to solve these, but yeah, we don't want this. But 1k equals 3, so therefore k equals the square root of 3. K equals the square root of 3. K equals the square root of 3, like so. K equals the square root of 3, like I've done. Any question, any suggestion, any input, anything else to add, any contribution to make?
No.
Nothing. Okay, good. Let's move to the next one. Right, 6.2.2 is not different, but the examiner is saying here, okay, we're still given the sine of 60 degrees plus 2x plus the sine of 60 degrees minus 2x. If cosine x is the square root of t, without using calculator, determine the value of these in terms of t. In terms of t. So what do we do here? What do we do first? First things first in mathematics, even when a question is difficult, but what you do first, you copy the question. It is actually the tangent of 60 degrees. And you have the sine of 60 degrees plus 2x plus the sine of 60 degrees minus 2x, like so. Then what do we do next? What do we do next?
It's 1060, which is
Yeah.
square root 3.
Okay, well done. The tangent of 60. So you just remind ourselves, remind each other, this is 60 degrees, this one is 90 degrees, our special triangles. And this one here is the square root of 3, 1, and a 2 here. The hypotenuse is of length 2 units, and I put a 2 here. So right now we have the tangent of 60 degrees. The tangent of 60 degrees is what? Obviously, we remember our old friend SOHCAHTOA. The tangent is opposite of adjacent. So we come here and then say 60 opposite of adjacent is the square root of 3 out of 1, which is just the square root of 3, as you said. So very well done to you for being able to remember that. Then what do we do next? Oh.
Then it's sine 60.
Sine 60, etc. But we've already got this one. What did you get this one to be?
Which one?
So this whole thing. So because we've already got it here, this sine 60 degrees plus 2x plus sine 60 degrees minus 2x is equal to what? Okay, we did it before. Right, so we got if the sine of this, it came down to
2x.
yes. So yeah, this one on the left of the equation, we worked it out and it came down to the square root of 3 times cosine 2x. Okay. So this we are good. So we're gonna write it here because we already know this whole thing here is the square root of 3 cosine 2x. I mean, we could do it again, but yeah, we already know it from the first question. So the examiner did not quite expect a repetition of the process there. Okay. And then what is the answer to this? So we have the square root of 3 times the square root of 3. What is the square root of 3 times the square root of 3?
It's 9.
Okay, y'all can write the square root of 9 if you like.
It's 3.
3. Okay, good. Yeah, not to write 3. If you multiply the square root, if you multiply the square root of x by the square root of x, you just get x. Okay, and then we have cosine 2x equals. Then what do we do next? Because we want to write this in terms of t. So yeah, what do we do here at this point? What do we do?
3.
Uh-huh. D, like so. Okay.
Oh,
Uh-huh. Cosine 2x. We remember that cosine 2x, because we've already been given cosine x, which is square root of t. So we're going to use, because cosine 2x is 2 cosine squared x minus 1, but it's also 1 minus 2 sine squared x, which is cosine squared x minus sine squared x. Okay, there are three identities. So for cosine 2x, because we have cosine 2x, so we can choose here. We can write 2 cosine squared x minus 1, or we can write 1 minus 2 sine squared x, or we can use cosine squared x minus 1. Which one would be the best one to use? The best identity to use? Or the most preferred? Most preferable?
Peter, please repeat yourself. Okay.
Yeah, okay. Which identity among 1, 2, and 3 would be the best one to use here? Because we have cosine 2x, I need to use one of the double formulae, just one of them. So which one is the ideal to use?
The first one.
Well done, the first one. Okay, so because obviously cosine 2x is cosine 2x is 2 cosine squared minus 1. So it is 2 cosine squared x minus 1, which is 3. Okay, 2. Cosine x is the square root of t squared minus 1, which is 3. Okay, if you square the square root, it becomes just t, so that we have 2t minus 1. And you multiply 3 times 2 is a 6t minus 3. And this becomes the answer to the problem. It becomes the answer to the problem, and therefore we have managed to solve this problem. And the answer is actually exactly 6t minus 3. Okay, we're done for the 3 marks there. So that is what, excuse me, that is what was expected.
T
And
is
this for the,
equals to half.
please come again.
T is equals to half.
Okay, yeah, we could say t equals half. Yes, t would be half if we could make the whole thing 0. But the examiner just gave us this expression without equating it to 0. So we just had to deal with it like that, you know. But obviously, I agree that if ever this expression were to be 0, equal to 0, equal to 0, equal to 0, which the examiner did not give us, it would mean, therefore, t equals 1/2. I agree with you there. Next question. Right, in the next question, you determine the general solution of this particular equation. What is the general solution of this particular equation? So, yeah, what would you do here, Noah? What would you do here? Mm-hmm.
2 times 2x.
2 times
2x.
2x. Okay. So, yeah, what do we write first? What do we write here?
Left hand side.
Left-hand side. Right, so the left-hand side, yeah, definitely, I agree with you. But now this one is the same as what? So it's the same as cosine of A minus B. Cosine of A minus B is cosine A, cosine B, plus the sine of A, and then the sine of B. And then the sine of B. Right, so this is going to be exactly the sine of B. Yeah, what do we do here?
It's going to be
So yeah, so the
cos
point is, yeah, so it's gonna be cosine
4x minus x.
4x minus x. Well done. Because if you see the plus in the middle here, see the plus here, it means that it must be minus there. Okay. And this is minus 0.7. So now, I mean, what do we do at this particular juncture? What is the next thing to do here?
Mm, reference angles.
The reference angles. Well done, Noor. The reference angles. Now we get our reference angles. Just teasing you. So yeah, we get the reference angles right. So you can write in small letters, usual. So you can write here the reference angle. So the reference angle is gonna be arc cosine of 0.7. 0.7. Okay. Right. So yeah, and then if you use a calculator, what are we able to achieve at these points?
35.57.
Okay, good. Okay, obviously I'm using my calculator as well to make sure that we get the correct answers here. We don't want to make mistakes. So I'm using my computer, my calculator here, so I'm just going to write that one down. And obviously you are most certainly in point. And we're good. We're so good, right? So obviously you have already used your calculator, and you're able to get the answer. And I'm checking mine as well. 5.3, 5.3, 5.3, 5.3, 5.3, 5.3. Right, so we're good. Right. Let's see what we have here exactly. Right, so we have this, and now let us continue to solve these particular questions here. Right, let's just do it. Okay, I'm going to launch my calculator as well because to make sure that we get the correct answers here. So we're going to do arc cosine of 0.7. Noah has already got the answer to that one. And right, so you have arc cosine of 0.7. Okay, I'm getting that one. Right, so, and what then we're able to achieve is 45. You got 45.57 degrees. Did you? Something like this.
Yes,
Okay, good.
I got
You got this, right? Or is it different? No, it's not different. Okay. Okay, now at this point, then remember our Gauss diagram. Right, remember our Gauss diagram. So the cosine is negative. Where is it negative? It is negative in the second quadrant, but it's also negative in the third. So which means therefore, now we're going to use the fact that now the 45, okay, yeah. There's something you can do here. For example, this one is the same as the cosine of 3x equals minus 0.7, which means therefore cosine of 3x, okay, equals minus 0.7. And therefore, we're going to deal with those two quadrants. So now dealing with the second quadrant, it's going to be actually 3x equals 180 degrees minus 45.57 degrees. Right. Or, and then we add 360 degrees by k an element of z, or 3x equals 180 degrees. They now want to also get to the third quadrant, which is 180 degrees plus 45.57 degrees plus 360 degrees by k an element of the set of integers. Okay, just getting the answer here quickly. Right, so I mean we have this here, and therefore let us see what to get as the answer. So I mean, if we have the cosine of 3x, cosine of 3x is the same as equal to exactly that one there, equals exactly that one there. Okay, your. Okay, so now this one is 3x equals. So, right, so if at this point you have this, and this is exactly 180 degrees minus 45.57. We're getting 134. 134, comma, 43 degrees plus 360 degrees by k an element of the set of integers, or 3x equals, okay, this is 200 and exactly 25.57 degrees 360 by k and z. So we continue. 134.43 divided by 3, which is exactly 44, comma, 81 degrees divided by 3, which is 120. Okay, so you divide right now 25.57. You divide it by 3, it's 75. So you have exactly 75, comma, 19 degrees. Okay, divide the 360 by 3, you get 120 degrees by k an element of the set of integers. That's the answer. That's the answer. That's the answer. What is the next thing that we need to do? Right, so we have solved this one and we found the general solution here to this particular question. And we proceed to solve these. The rest of the other questions is step-by-step session. And we are very excited to solve more problems here, because we are good students and we want to make sure that we get the answers that the examiners want. Right, and obviously without further ado, we actually proceed to the next one. It is my hope that there's no question. Any suggestion now? Maybe there is a number that is missing. There is something we need to add or something to remove. Anything like that?
No.
No. Thanks, Nemo. Right, so next question. Right, we need to prove this particular identity. We need to prove this particular identity. So now to prove this particular identity, there are a couple of things that we need to take into account, and we need to proceed to prove this with so much ease. Let us prove this one with Neville. What do we do here now? Okay, we need to prove the identity. Just to take you up to speed, to familiarize you with the question. We have been given sine 4x times cosine 2x minus 2 cosine 4x times sine x times cosine x, all divided by 10 to x equals cosine squared x minus sine squared. So what do we do here? What do we do here? Too easy.
Sine 2 times 2x.
Okay, so yeah, we need to take one side. So we take the left-hand side, I presume. So what do we write here? Okay, if you take the left-hand side, you copy the question. You copy the left-hand side as it is. You copy the left-hand side as it is. And then you divide by the tangent of 2x. So what do we do next?
Sine 2 times 2.
The sine of 2 times 2, right? Yeah, I agree with you. That is something we can do. That is something we can do. But if you look at sine 4x, cosine 2x, and then this one you can write cosine 4x, and then you allow the 2 to go in, and you have 2 sine x cosine x, and it is all divided by the tangent of 2x. The left-hand side, which is exactly the sine of 4x, cosine 2x, cosine 5x. What is this one? This one, the 2 sine x cosine x is the same as the sine of 2x, all divided by the tangent of 2x. Yeah. So what is
How
this?
do you 2?
Please come again.
Step 2.
How did you get these 2?
Step 2.
Or step 2? Yeah, okay, good. That's fine. Step 2, let's talk about step 2 now. So obviously we had this guy here with this. So cosine 4x is the odd one out, so we took it out, and then we're left with 2 sine x cosine x. So we have 2 sine x cosine x, and we regrouped the terms. So we did regrouping, right? When we did regrouping, we then got 2 sine x cosine x. But 2 sine x cosine x is the same as what? 2 sine x cosine x is sine 2x. Right? Okay, because we remember that sine 2x is the same as 2 sine x cosine x. Okay, we applied that. And when we get to the point, it is very clear that the left-hand side, okay, so what identity do we use here for this?
So by the second step,
Yeah, second step, this one.
negative cos 4x.
Yeah, negative cosine for x, which is this one, which is cosine for x, this one. Cosine for x.
Why?
Cosine
You
for x.
took out negative x. And then you left 2.
Which, like here.
By the second step.
Okay, second step.
Did you factorize or what did you do?
What did you do here? Okay, that's a good point. Did we factor? Yes. So we took out cosine for x. And if we factorize cosine for x, we're left with 2 sine x cosine x, right? So we factored out cosine for x, leaving us with 2 sine x cosine x. And the 2 sine x cosine x is what gives us the sine 2x.
So you factor out
Yeah, we
negative
factor out.
cos.
Yes, we factor out negative cosine for x. Yeah, correct.
You took out negative cos 4x,
Yes.
but it's different from cos x. So
Please come again. I'm trying to understand what you mean.
it's different from cos x.
Is it different
So
from
how do you factorize that?
Okay, yeah, okay. Because we were having what? Okay, let's read it together. We're having minus 2 cosine for x, sine x, cosine x with these. So, okay, we do. Okay, so we can take out this one with the negative. So if you have minus cosine for x, minus cosine for x, which is 2 sine x cosine x. Right, so we took out minus cosine for x, and then you're left with 2 sine x cosine x, and which is minus cosine for x, and therefore this 2 sine x cosine x is actually the sine of 2x. Is the trigonometric sine of 2x. Trigonometric sine of 2x. Yeah, which is this, right?
Okay.
Yeah, try to think about it. And then now this one is it's a nice compound angle formula. What is the compound angle formula for sine of AB minus? So sine of AB minus becomes sine of the A is cosine, and then you subtract the 2x all over tangent of 2x. And then now this point is equal to, what is the 4x minus 2x? Is 2x over the 10 of 2x. The tangent of x is the same as the sine of 2x. Okay, it is exactly the same as the sine of 2x over cosine 2x for the denominator. Okay, let's proceed here on the further right of the board. And I want us to therefore now deal with this, the right hand side, the left. Okay, so we have this, you divide by sine 2x over cosine 2x. We multiply by cosine 2x sine 2x. Okay, so this one cancels out, giving us the left-hand side, which is cosine 2x. Okay. What is cosine 2x? Is it equal to this? Is it equal to cosine squared minus sine squared? Yes. It's equal to cosine squared x minus sine squared x. It's the double angle formula, and this is the right-hand side. Right? And obviously, as a conclusion, therefore, the left-hand side equals the right-hand side. Any question now or anything to add as we prove this identity, any contributions, anything to subtract?
I'm still writing.
Oh, okay, that's fine. A very interesting question that came from one of the, right. Right, so we're good. We're good. Perfect. Right. Right, so.
Yes, it's fine.
Okay, it's good. Right, so this is one question that was given to us, and it was a very, very awesome question that we had to solve. Right, I think that we have, the time is 12 o'clock, midday. And we can take a break. And I'll keep you posted of more questions on WhatsApp. Okay, I'll keep you posted of, because the time is 12 o'clock and we're supposed to start at 10 to 12. You know?
Yes.
Yeah, I still have like lots of questions. We still can continue, but it's some good time to take a break, relax. But I'm gonna keep you posted on WhatsApp. But also,
Okay.
yeah, I'll indicate what else we need to do to improve skills on this topic and to make sure that we shape better. Right, so it was awesome having a discussion this day, this Good Saturday. Right, so I'll keep you posted once again on WhatsApp. Right, from us, enjoy your afternoon and have a happy Saturday. And goodbye
Okay.
now, Noah. Goodbye, Noah.
Yes, sir.
Goodbye, Noah.